The figure shows the architecture for data acquisition. The figure provides an overview of the possible loading scenarios in SAP Business Warehouse or BW. The most important part of this is the flat file interface. All types of data can be loaded into SAP BW with files, including text, master data attributes, hierarchies, and transaction data. SAP BW supports the transfer of data from flat files, files in American Standard Code for Information Interchange or ASCII format, or comma-separated value or CSV format. For example, if budget planning for a company's branch offices is done in Microsoft Excel, this planning data can be loaded into SAP BW so that a planned actual comparison can be performed. The data for the flat file can be transferred to SAP BW from a local workstation or from an application server. Note the following with regard to CSV files. Fields that are not filled in a CSV file are filled with a blank space if they are character fields, and with a 0 if they are numerical fields. If separators are used inconsistently in a CSV file, the wrong not defined in the data source separator is read as a character, and both fields are merged into one field and possibly shortened. Subsequent fields are then no longer in the correct order. Note the following with regard to CSV files and ASCII files. The conversion routine used determines whether you have to specify leading zeros. For dates, you usually use the format YYYYMMDD without internal separators. Depending on the conversion routine used, you can also use other formats.
Transaction data has no fixed format. The transfer structure in SAP BW simply has to correspond with the file layout. Hierarchy data and text data have fixed format requirements for the file, whereas with master data attributes, the attribute data fields can exist in any sequence, provided they correspond with the fields in the file. The keys, however, must be at the beginning of the file layout. Before you can load flat files, a file system must be created as the source system of the SAP BW system. You can create a file system on the Source Systems tab in the Data Warehousing workbench. You need to have only one file type source system. The actual location of the physical file is determined in the data source and can reside on the application server or on a local workstation.
In addition to the functions already described, the following functions also ensure stable data extraction. Exclude certain header rows. Selection options to filter the file when loading. Routine for naming the physical file. Extensive preview functions. File loading processes are extremely flexible. Not all of the functions named above are needed for every loading process. However, if they are needed, they are very helpful.
If you use the file data source, you need a process to create or regenerate the file needed by SAP BW at the right time. In some instances, this can lead to errors. For example, the external application that provides the sales data.csv file can contain data from the previous month. This is a considerable problem because SAP BW loads the wrong data, and this might not even be noticed. The Extraction tab contains the Create Routine option. When you use this button, a different file name can be generated every time with the help of an Advanced Business Application Programming or ABAP routine. Instead of sales data.csv file name, the routine will generate the name JAN2005_salesdata.csv. The external application would then have to create the file with this dynamically generated name. If this is not the case, SAP BW cannot find the file and a loading error occurs. The corresponding email warning messages are also displayed. The problem is detected in this way, and duplicated data is not loaded by mistake. When you upload external data, you are able to load the data from any workstation into SAP BW. However, for performance reasons, you should store the data on an application server and load it from there into SAP BW. This means that you can also load the data in the background. If you want to upload a large amount of transaction data from a flat file and you are able to specify the file type of the flat file, you should create the flat file as an ASCII file. From a performance perspective, uploading the data from an ASCII file is the most cost-effective method. Under certain circumstances, generating an ASCII file might involve a larger workload. An additional option is specifying a logical file name. The physical file path and name can then be defined in the transaction FILE. Variables to determine the physical file name or path could also be used there. This is not a transaction that is specific to SAP BW. Without descriptions in the file, it is not easy to check whether a file has the correct information or even if the correct file has been selected. The descriptions are normally found at the beginning of the file and can contain column headers and details of the time of creation or the creator of the file. This metadata, that is, descriptive information or data about data, should be ignored. You can control this using the number of headers to be ignored option on the Extraction tab of the flat file data source.
As there is no replication of metadata for a data source when you upload flat files, you must reproduce the field sequence in the data source. On the Proposal tab page, you can create a proposal for the field list of your flat file data source based on the sample data from your CSV file. You can specify how many data records you want to load and choose the Load Sample Data button. The data is displayed in the format of your file in the upper part of the tab page. The system displays the proposal for the field list in the lower part of the tab page. Where necessary, remove the Copy to Field Lists selection for fields that are not to be transferred to field list. A data source for an SAP source system can be configured in such a way that the data is filtered before staging in SAP BW and takes place in the source system. With file systems, this is done by selecting the corresponding values from the selection list for the desired filter fields on the Fields tab of each data source. Options for handling field proposals are as follows. By setting the transfer indicator, select the fields that should be provided for extraction. If required, specify info objects of the SAP BW system for the fields under Template Info Object. The system proposes them for assignment to a field when defining the transformation. It is possible to transfer the technical properties of the info object to the data source field. If required, change the data type of the field. If required, change the output length for a field. If required, change the values for the key fields of the source. These key fields are generated as a secondary index in the persistent staging area or PSA. This is important in ensuring good performance for DTP sections, in particular with semantic grouping. Define if lowercase is supported. Specify whether the source provides the data in an internal or external format. If required, specify a conversion routine that converts the data to internal format. Select the fields for which you want to be able to set selection criteria when you schedule a data request using an SAP BW info package. Data for this type of field is transferred according to the selection criteria specified in the info package. Choose the selection options such as EQBT to be provided for selection in the info package. If required in the field type, define if the data to be selected is language dependent or time dependent.
On the Preview tab, you can select Read Preview Data and Data Records according to your field selection are displayed in a preview. With this function, you are able to check whether the data formats and data are correct. This can be a very useful function that enables you to ensure that the technical field definitions are loaded in the correct sequence without actually loading the data using the SAP BW staging process. You can make settings in SAP BW so that the system expects and checks two different delta processes.
With the delta process FIL0 delta data after images found on the Extraction tab, the SAP BW system expects an after-image record with the new status of a record. If a legacy system only recognizes the current or new status of a change, you have to use the data store object override function.
After the data has been updated to the change log for the data store object, by activating the data store object data, it can be made available to other standard info cubes or data store objects with the additive data, which can then be processed by the respective target info provider. With the delta process FIL1 delta data, delta images, the SAP BW system expects either a record with a difference or two records, one with the after image and one with the before image. The file system does not process the record mode. Therefore, the record mode X that would reverse the +/- sign cannot be used if the system is not an SAP source system. The before image must already show a reversed +/- sign for the key figures. If the data source is defined as additive, use either an additive image or both images before and after. In this case, a warning is displayed if the data store object is set to overwrite. You will be informed that this activity is not permitted. You can only use the addition setting in the data store object for additive file data sources.
If a data source is set to full upload, that is, data from info package selection only, the normal delta loading process, that is, delta initialization load and follow-up delta loads is not available. However, you can resolve this by working with a pseudo-delta. A pseudo-delta is not really a delta process at all, hence the adjective pseudo. You do not have to constantly delete and reload the entire standard info cube, only the data that might have changed. The difficulty is in finding out which records might have changed. Internal or external legal regulations can dictate that application data can no longer be changed after a particular period of time has elapsed. An example of this is accountancy data, which cannot normally be changed retrospectively, except perhaps for the current period. Filters in the info package and the deletion of the same record area in the standard info cube ensure that only changed data is reloaded and that this data is not duplicated. The processes that are required for a pseudo-delta are time-consuming and are prone to errors. You can automate the process to guarantee accuracy and consistency. In the first step, a variable is automatically used for the period to change the filter settings dynamically. In the figure, the SAP variable 0CMONTH is used to change the selected month automatically to the current month. You can also determine the selection criteria with a user-defined routine.
Hierarchies provide flexible, easily changed roll-up groupings for reporting in SAP Business Explorer or BEX and SAP Business Objects reporting tools. Although the reporting uses and manual maintenance features of hierarchies have not changed, the extract, transform, and load or ETL process for loading hierarchies to SAP BW was improved with SAP BW 7.3. The older 3.x ETL process for hierarchies was used up to version 7.3. For version 7.3 and higher, hierarchies have been fully integrated into the latest ETL processes for SAP BW. This includes both loading and exporting via an open hub. The figure highlights the SAP BW objects used in the older 3.x flow. This ETL flow is still supported, although SAP recommends that newly created data sources that can be created on all types of sources systems use the newer 7.3 flow objects. It is also advisable for the sake of simplicity and the additional features to convert older ETL processes for hierarchies into the latest one if time allows.
In both the old and new scenarios, the system breaks up a flat loading structure into multiple segments. Each segment supports one of the underlying tables that store the hierarchy structure. The segments include the hierarchy header, hierarchy description, hierarchy structure, and descriptions for the text nodes. As of SAP BW 7.3, these segments are much more usable in transformation logic. The older flow had flexibility issues, as you can see in the following list. In addition, hierarchy export via Open Hub was not possible. These issues have been resolved, but for the purpose of compatibility with older versions, the old flow is still supported, and existing file definitions can be loaded with both the old flow work and the new one. Up to SAP BW 7.0x, hierarchies could only be loaded through 3.x data flow. Other than the heterogeneous data flows, the 3.x data flow for hierarchies had the following disadvantages. Hierarchy data sources were only available for SAP source system and flat files. There were limited transformation and content delivering capabilities, with examples as follows. No start routine for hierarchy transfer rules. No possibility to change the hierarchy structure during runtime. You needed complex scenarios to change the hierarchy, such as Analysis Process Designer or APD. No flexible update of other data targets. No update rules.
As of version 7.0, the new hierarchy ETL process has been updated to include all the ETL features that existed for other objects, that is, info cubes, info objects, data store objects, or DSOs. This flow includes the ability to do multiple manipulations of the structure, descriptions, or attributes of hierarchies via 7.x info sources, and the use of data transfer process or DTP and transformation objects. Although the basics are the same, the new data source for hierarchies now controls the file format, as opposed to the info package, as was the case prior to the SAP BW 7.3 ETL for each segment of the hierarchy, and the flexibility to load hierarchies using both the layouts defined by the old hierarchy framework and the newer one. As shown in the figure, the load format changes to the new one when you choose the Hierarchy is Flexible option. Other notable features of the new data source include the ability to review each segment of the hierarchy and preview the data.
Another significant improvement in usability is the ability to easily create the hierarchy header, that is, the name of the hierarchy to be loaded and the version, and to have the expected format change from the older version to the new version. Even when using a new 7.x data source for the hierarchy, the expected format could be the old or the new one. The older format, which is still needed to maintain compatibility with older versions, had the info object or compound info object embedded in the node ID when characteristics were used as nodes.
The two different formats, that is, old and new, are shown in the figure. You need to know which format you have. When migrated, older flows will still use the old format, unless you change the file structure, which is not always necessary. The details of the format are shown in the figure. The fields in the new format contain the details of nodes that are built from characteristics as opposed to just text. The new rule type is called hierarchy split. This is needed because NODE name includes the info object and compounding in the old format. This transformation option, which you use in the exercise, load a hierarchy using the hierarchy framework, only works if the field lengths have not been changed. If the SAP delivered transformation does not work in your situation, you may have to write your own parsing formula. The info object at the top is 0OBJECT-ID, that is, Object Identification in Segments. It is only used if several hierarchies are loaded in one request. As only one hierarchy is normally supplied per request, this is not relevant for normal data sources, and in most cases, it remains unmapped. The remainder of the load process is very much standard. Info packages load to the PSA and the DTP runs them into the hierarchy tables. The only technical aspect that might be of interest is that the PSA is actually multiple PSAs, one for each segment of the hierarchy, to allow greater flexibility when processing the transformations. When you manage the data source and display the data, choose which segment of the data should be displayed, that is, hierarchy header, text for nodes, or structure at the bottom of the screen.
As of version 7.3, hierarchies can be exported via OpenHub. Like other objects, the export uses a data transfer process or DTP and a transformation and can put the data into a file or table. Again, just like the previous features for other objects, the output for file exports includes both a data file with a tree structure and a metadata file to define the fields included in the data file. The only major differences in using OpenHub with hierarchies as opposed to other objects involves the need to pick the hierarchy subtype and to ensure that you filter the DTP to choose only one hierarchy. The output from OpenHub can be a file or a database table. The latter is a standalone object, but the file option will generate two separate CSV files. One is the data of the hierarchy structure, the other defines the fields. Hint: the output from the hub export will have fields that you will not need if you want to reload it later using a data source after offline manipulation.